class, wait for another 1 minute. Okay. Okay, so everyone here, Praveen, first, movies are 6, 9, 10. Okay, so class. So let's see, start. Okay, I think I asked you to do something, the graph. So you try to sketch the graph. Okay, let's sketch together. Okay, so I asked you to sketch an object drop. Okay, right. So from a certain height, there is enough. Okay, I told you like an object was dropped from a certain height, bounces several times. Draw the VT graph. Okay, so first I want you to draw the VT graph. Okay. Okay, so how do you draw the VT graph? Okay, first take downwards as positive. Okay, take downwards as positive. So take downwards as positive. Okay, so first tell me, the graph going to be a straight line, curve, or flat line? Is it going to be a curve? Is it going to be a straight line with a gradient, or it's going to be a flat line?
Straight line with gradient.
Yeah, it's going to be a straight line with gradient. Why?
Because acceleration is increasing. No. Acceleration is constant.
Very good. Acceleration is constant. Acceleration is constant, so gradient have to be constant. So the VT graph going to be a full of straight line with gradient. Okay, now first, is it the graph going to start with positive, 0, or negative? Downwards as you drop from rest. So the graph going to start where?
0.
From 0. Okay, the graph going to start from 0. When you go down, okay, the velocity from 0, it might increase magnitude 10. It's going to be positive 10 or negative 10. Downwards is positive. It's going to be positive 10, positive 20. So the velocity will rise until it hit the ground. So how the graph looks like? Just moving down, only moving down. Graph going to go up or go down? It will move up. It will move up. The straight line move up. Okay, it's going to be a straight line move up. It's number 1. Okay. Why it move up? Because velocity is positive. Okay, now the second one. This is the challenging one. Second one. After rebounces and going up until reach the top again, how's the graph going to look like? When it hit the ground, positive 30. Okay, so I go back. At the moment when it hit the ground, imagine it's like positive 30 meter per second. Okay, imagine it's positive 30 meter per second. Okay, when it rebounces, the magnitude of the velocity going to be smaller than 30 or more than 30 or same as 30? Anyone?
It's
Smaller.
Slightly smaller, maybe 28. 28 because some energy is lost to. Why is smaller? Reason? Some kinetic energy has been converted to maybe heat or sound. So kinetic energy should drop, so it's smaller. positive 28, let's say it's 28. Positive 28 or negative 28? Rebounces. So it's going to be negative 28. Why negative 28? Because
Goes opposite direction.
opposite direction. So here in the graph here I put like, imagine this is positive 30. So when it rebounds, it immediately go down. Go down to what? Go down to
Oh, negative of the same value.
negative 28. Negative 28. Then when it moves up, what happened to the velocity? Negative 10, maybe negative 8, finally becomes 0. So how the graph going to look like? You're going to go up until reach 0. Okay, so this is the first cycle of rebouncing, moving from 1 and 2. This is the second one. Okay, this is the second one. Okay, this is the second one. Okay, so now this pattern going to repeat. Okay, this pattern going to repeat. So now we're going to draw the third one. Third one. After achieve a new maximum height, which is shorter than the earlier one, it goes down again. How's the graph going to look like? It will still, this pattern, the first pattern going to repeat. Okay, but what is the difference? Is it going to go up with the same height as positive 30?
No.
No, smaller. Is it going to reach negative 20, positive 28?
No.
Is it going to reach positive 28? Avoid air resistance. Without air resistance. Without air resistance. It bounces up with 28, negative 28. When it reaches the ground, is it going to be 28 again?
No.
If no air resistance, it will. If no air resistance, it will reach 28. Okay. You throw an object with 10 meter per second means it should reach your end back again with 10 meter per second, but in opposite direction. But the magnitude will be 10 meter per second if no air resistance. That means if you do this experiment in the surface of the moon, you will get the same. In A levels, they will ask question like ignoring air resistance sometimes. So it should be this graph without air resistance. So it should reach, here should be positive 28. Positive 28. If this is negative 28, here will be positive 28. And what happened? This pattern repeats. This pattern will repeats. Finally, it stops. Okay. This is your VT graph. Okay, this is your VT graph. Please sketch the graph on these notes. Okay, very important graph, VT graph. Zigzag going up and down. Okay. Okay, so now I'm going to ask more questions from you. Okay, label this. This is A, point A. This is point B. Okay, this is point C. This is D, and finally this is E. Okay. Okay, I put further F and G. Okay, so you have A, B, C, D, E, F, G. Okay, tell me my question. Answer my question. Tell me, when the object is launched, where it for the first time it touches the ground. At which point? Yeah.
B.
B. Good. It touches the ground at B. It started to touch the ground at B. Okay. At which point it start to take off from ground, detach from ground.
D.
D. Very good. D. D start to detach from the ground. That means remember B, C, D. It was touching with the ground. Okay. Tell me. The triangle here, area is 1. The triangle below here, I label it area as 2. And the triangle, the third triangle here, I label it as 3. Tell me which area must be same with the reason.
2 and 3. 2 and 3.
2 and 3. Why?
There is like
The 2 is actually the height.
like a bounce.
Yeah, okay. So 2 is the height it rises. So height it rises is the same as height, the distance it fall down. So 2 rises by 5 meter means 3 you should fall down with 5 meter. So 2 and 3 must be same area. Area in the graph tells the displacement, right? Displacement. Okay. So 1 greater or 2 greater? Area 1 greater or 2 greater?
Area
Yeah,
one.
area 1 greater, because you drop from a certain height, 5 meter, let's say, when it rebounds, it might achieve 3 meter back. So the 5 meter is the area 1, 3 meters the area 2, rebounds the side. Okay. Another one feature I want to ask you, the two line here, see I'm marking here like an arrow. These two line and this line, these four lines must be parallel or necessary must be parallel. It must be parallel or not necessary must be parallel. Anyone? The lines have to be parallel. Is it have to be parallel or not necessary must be parallel? Give a reason why. The
Constant acceleration.
yeah, so the gradient is the acceleration. So it must be parallel or not parallel?
Parallel.
Must be parallel. Why? Because acceleration is gravity 9.81. So all gravity must be the same. So it should be parallel. Okay, remember in exam, if they ask you to sketch, make sure the lines are parallel. Okay, lines are parallel. Okay, good. So this is your VT graph. Okay, this is your VT graph. Okay, now can you draw the AT graph? How's the AT graph looks like? Go for the AT graph first. Let me expand this. Okay, this is your VT graph. Okay, can you draw the AT graph now? Graph. Okay, we go for the number one. For the case of number one, AT. VT graph is a straight line with a gradient. AT graph going to be what? Is it a curve? Is it a straight line with a gradient, or is it going to be a flat line? One. So it's going to be a
Flat line.
it should be a flat line. The generation, as I told you last class, it should be a flat line. So one positive or negative? Flat line with positive, right? Positive one. Of course, we know it's positive, like 9.81, because the gradient is positive. So two also going to be the vertically straight line. We don't consider the two because no time interval. That's why we never consider it. So two also going to be a flat line. So it's going to be a continuous flat line. The 2, the 3, the 4, all connected, it's going to be a flat line. So AT line is just a flat line. Okay, positive 9.81. Okay, the gradient is the graph. Okay, let me rub this. Okay, now the challenging one. Can you please sketch for me the ST graph? This is where it's challenging. ST graph, anyone? Is it going to be a curve? 1, 2, 3, which one? ST.
1.
So it's going to be a curve. But curve got 4 types, going up like this, coming down like this, as I told you. 1, 2, 3, 4. Okay, look at for the first one. The velocity is going up from positive 0 to 30. Which curve you attach into the ST graph? 1, 2, 1. Yes, good. Should be 1. Because gradient is 0, become highly positive. Velocity 0 become, so it's going to be 1. You go up 1. Okay, this is for the first one. Okay, so this consider the ground. This is your ground. This is your ground. According to our graph, it's the ground. Okay, now the immediate statement you can't draw. Can you draw the 2? Just 2. 2 means only the lower part, the 2. Going up, 2. How this graph looks like? 2. 2 is just from here to here, 2 for the VT. The velocity is what? Negative become 0. Negative becomes 0. So which curve? 1, 2, 3, 4.
4.
4. Yes, good. Negative become 0. Highly sliding negative gradient becomes 0. So you need to attach the fourth one here. So it's going to be a fourth one. Okay, fourth one. Fourth one like this. For the second one here, the velocity graph. This is how the curve should look like. But do it going to reach the same height? Is it going to reach at the bottom? Same height as the earlier one?
No.
No, right? Because the height it rises is shorter than the earlier one. So it's going to be halfway somewhere here. Any questions? No questions, eh? So it'd have to be a curve. The curve for the second one should be velocity from negative to zero. So the curve must be sliding, highly sliding negative and zero. So the fourth curve. Okay, now this pattern going to repeat. This is one full bounce already. Coming down, hit and going up. So this V shape kind of this pattern going to repeat back. So what do you do? The following one is going to go up again, then coming down like this, shorter. Going up again, coming down shorter. Going up again, yeah, this repeats. This is your ST. This is your ST graph. Okay. First, please make sure you draw these three graphs. Your AT, your VT, and this is the ST graph by considering downwards as positive. Okay, downwards as positive. Okay, so please draw it on the paper. Later you put it into the notes. Okay, it's up to you. You write in whatever it is. These are the three graphs you have to sketch. Okay. Any questions? Okay.
No.
So now we go to the next one. Can you draw these three graph back? Can you draw these three graph back? Now taking upwards as positive. Take upwards as positive. How this graph going to look like? Okay, first draw the VT. Upward as positive. Okay. So let me, because I want to sketch, I will draw here itself. How's the VT graph looks like? VT graph looks like upwards as positive. So where your graph going to start? You're going to start from 0. Okay. Okay. We are following this diagram. It's going down. Last time was positive 30, but now it's going to be, because upwards is positive. That means downwards is negative. So how the graph going to look like? Going down or going up? Going down. It should go down. Down to negative 30. So what is the conclusion? Similar graph going to repeat again, but like a reflection to x-axis. So it's going to be like this. Sorry, it's going to be like this. VT graph. Upwards as positive. Okay. How's the AT graph going to look like? AT graph. Anyone? It's a straight line, flat line, but all the gradient are negative. All are negative. So AT graph going to be negative 9.81. So it's going to be a flat line throughout. It's an AT graph.
So I have a question.
Yeah.
The AT line is all straight. It's not like it's gonna jump from positive to negative.
That's the main issue. Students from Form 5 to A levels have a problem. When I was in Form 5, also I have the same problem. Okay, because no, you see, what causes acceleration? Gravity, right? Gravity causes acceleration, right? Gravity acting which direction?
Down.
Down. The gravity is the acceleration. Is the direction of gravity change?
Oh.
Never change, right? Gravity always acting down, right? If you take upwards as positive means gravity acting down is always negative. So it's always negative, never become positive.
Okay. So we are not counting the acceleration of that object as it is.
We actually no.
Yeah, like for example, when it touches the ground and then it goes up, isn't there an acceleration to go opposite of the gravity for a while and then it goes back down, bounces and then static?
You mean during collision? Not
During
the
collision,
bottom.
it goes up again.
Going up, coming down. Okay.
Yeah.
We're not okay. Let me. This is a crucial one. Okay, let me rub this. I teach you that. Okay, so let's say an object is we take this one. We take upwards as positive. We take upwards as positive. So when object is going down, the gravity is pulling it down.
Yes.
So the acceleration is negative 9.81, right? The acceleration is negative 9.81.
Yes.
When the object is going up, okay, where's the gravity acting? Still,
Now.
gravity is still down. So still negative
Oh.
9.81.
So.
So A is
So.
still negative 9.81.
Okay.
I know your confusion because last time later when you go up, you take when you calculate, you take A is negative 9.81, right?
Yeah.
When an object is coming down, do you take A as positive 9.81, right? You did this
Yeah. Kind of like
when
that.
you calculate, like you swear, the V equals U plus AT. That's what we're going to do the next part.
Yeah.
Uh, Actually, this technique, changing A negative 9.81 become positive 9.81, there is not say there is a mistake. When you do the first part, you never realize this. When you took the first part going up, you took upwards as positive.
Yeah.
You took upwards as positive. When the object going down, you took downwards as positive when you calculated, but you never realized this upward positive, downward positive last time.
Oh.
Now we need to realize this. You indirectly have changed this. You took downwards as positive when you go down. That's why you took positive 9.1. Okay, but
So.
when it come to graph, you see this VT graph, the A is always negative one. So always negative 9.81.
Oh, okay.
Okay, but this part will be clarified the next part because next we're going to be the motion equations. Okay.
Alright.
Okay, class. So this is your upward as positive and downwards positive. Okay, in the sketching graph, we did the earlier graph, then we did this movement under gravity, which they're going to ask the most is, of course, the gravity one. This is the most important. They will ask the most. Okay, let's go some questions before we continue. Okay, I go back to the question. So this some questions. Let's see the question there. Okay, this question. This is your Juno 3, question 9. Okay, read the question first. 1 minute for you. Ball is released from rest above horizontal surface. The graph shows variation time. The ball is released from rest above horizontal surface. Tell me from the graph, downward they take it positive or upward they take it as positive?
Good. That's positive.
Take downwards or upwards as positive?
Downward.
Downwards as positive. Because velocities become positive at the beginning. Okay, so now go back to the answer. What is your answer? Okay, you can put it your answer in the chat. Let me see. Majority score what? What's the answer? Read up. Put it in the chat box. What's your answer? Area x and y are equal. Why? Because of what? The ball acceleration is the same during upwards and downwards. A, B, C, D. Which one do you think should be the correct one? You must choose the best answer. Why the x and y same area? C. Okay. So B, C, D. Okay. So B, C, D, we have a variety of answers. Okay. Give another 1 minute, please. Everyone give your answer. I want to see how many of you can get correct hint. Okay, so B, C, D, B, B, D. Okay. D, B, D, D. Okay. Okay. So I think 50% go for D, kind of like that. And B also many. Okay, let's see. P or D? C. A ball acceleration is the same during the upward and downward motion. A is correct. It's a correct fact, but never explains about the area. So A is out. Although it's a correct fact, but never explains about the area. Okay, we're asking A, giving the C fact. Okay, so A out. B, the speed at which the ball leaves the surface after an impact is equal to the speed at which it returns to the surface. Okay, it's not wrong. It's correct again. Without air resistance, B is another fact is correct. That means the value here, negative 20 means value here should be positive 20. We're just talking about the maximum value. Okay, but it never explained about the area one. The speed it leaves, speed it reaches, never explains about the area. Area involves what? Area is involves about the distance traveled, right? So the answer must be something to do with the distance. So B, although is a correct fact, but never explains the area, because area is about distance, not about speed. So B cannot consider as answer. Okay, just talk about speed, not talk about area. Area is not speed. Area is distance. Okay. So C, for an impact, the speed at which the ball hits the surface equal to the speed at which it leaves the surface. Oh, this is totally wrong. Impact, when you hit the ground with 30 means it bounces back. Not going to be 30, definitely going to be less than 30. So C cannot be the answer at all. It's wrong fact. D is the answer. The ball rises is the same distance between the impact. The ball rises and falls through the same distance. X is the height it rises. Okay. X is the height it rises. Okay. So, of course, height it rises should be same as height it fall down. The height same, and the height both same. So, because same, the area will be the same. Okay. So, therefore, D is the answer. So, those who got D, good. So, in Cambridge, they give fact which is correct, but you have to think carefully which link to the answer. Any problem here? Okay, everyone agree. D is the answer. Rises is same as the distance is fall down. Okay. Okay, more questions to understand this? Okay, class. I think I need to do something before we continue. I need to teach you. Okay. Okay, class. So for ST, VT, and AT, okay, for an object free fall, going down, is taking upwards as positive. Remember, we're taking upwards as positive. The ST graph, the VT graph looks like what? Like this. Okay, it was like this. And AT graph was negative. And ST graph become what? ST graph will become from zero to negative. So it's going to slide down. It's going to slide down like this. Okay. So this is the object fall down without air resistance, no air resistance. Okay, no air resistance. Okay. So how's this graph this three graph going to change? Okay, I'm just going to draw only for the part one, only for the part one, only for the part one. That means just considering moving down only, just considering motion of moving down only. Okay, how's the ST graph going to look like? ST graph going to look like
Curve down.
curve down like this, curve down like this. How's the VT graph looks like this, how's the AT graph looks like this. Okay, now my question is, okay, just one, only one, easier. How this three graph going to change if air resistance is considered? If air resistance is considered, how this three graph going to change? First, I want you to sketch the VT graph. Okay, class. I just want to change something. This three graph is going down upwards as positive. Okay.
Oh.
If you take downwards as positive, this graph going to be the other way around, right? I think I go to the downwards as positive easier, because in most of the questions I think they go for downwards as positive. Okay. Let me rub this. Okay. So this tree rub this. Okay. It's not the graph. So if I take downwards as positive means how's the VT graph looks like? VT graph going up, right? ST graph going up like this, right? How's AT graph? AT graph is positive, right? Okay. So now tell me, this assuming a straight line. So how's the VT graph looks like if you consider air is? There is the air resistance now. What will happen to the graph? So when object is going down, okay. Sorry.
Oh, is this because of terminal?
Yeah, good. Someone said some important term. What is that? Terminal
Velocity.
achieved. Terminal velocity achieved. O level, do you learn terminal velocity? O level. Heard of terminal velocity? Okay. Terminal velocity will be achieved. Why terminal velocity achieved? Because when an object is going down, what are the forces acting? The weight is acting down, but now you have air resistance. You have what? You have air resistance. The air resistance, anyone? Proportional to what? Air resistance proportional to what factor? What factor rises, air resistance rises? Anyone? What factor rises, air resistance rises?
Speed.
Yeah, speed. Very good. Speed. When speed rises, air resistance rises. Good. So the air resistance proportional to speed. When an object is going down, when the time zero from rest, okay, the acceleration will be exactly same as 9.81. Okay, exactly same as 9.81. But when the speed builds up, air resistance will started to rises. Air resistance started to builds up. So after certain time, maybe after it dropped, maybe after 5 seconds later, it's falling down very far away. The air resistance already have a value now. Maybe the weight is 10 Newton. The air resistance may be built to 7 Newton, let's say. So what happened to the acceleration now? Is it still going to be 9.81 or smaller than 9.81? The acceleration going to be maybe smaller, of course smaller, maybe because the net force is only 3 divided by the mass of the object will give you the A. The A definitely gets smaller, maybe 5 meters per second. So the acceleration drops down. Okay, because why it drops down? Net force is dropping. Last time net force is exactly mg at the time 0. So mg equals to ma. Your A gives you exactly g when the time 0 9.81. But now after 5 seconds, air resistance builds up. The net force drop less than 10 Newton. So your A drops. So finally this continues until when, what happened?
A equals to 0.
Ah, very good. The air resistance maximum going to become what? It's going to reach to same as the weight, 10 Newton. When air resistance achieve 10 Newton, the acceleration become 0. This is the moment, a unique moment. We call that the system achieved what? Terminal velocity. Terminal velocity is achieved. Okay. Terminal velocity achieved at this moment. What is terminal velocity means? A type of velocity is a maximum velocity or a minimum velocity ever achieved by the object.
Maximum.
It's a maximum. V terminal achieved. Okay. V terminal means is the V max ever achieved by an object in air resistance. Okay. Remember, terminal velocity only relevant where there is a air resistance. If no air resistance, you won't achieve terminal velocity. You just keep on going down with acceleration of 9.81. Okay. So terminal velocity, the term is only involved when there is an air resistance. So V max achieved. When the V terminal achieved, two quantity becomes 0. One is the acceleration becomes 0. Another one quantity becomes 0. Anyone? When terminal velocity achieved, two quantity becomes 0. Acceleration becomes 0. Another one quantity becomes 0. Anyone?
Air resistance.
Air resistance is 10 Newton maximum. Air resistance.
Resultant force.
Yes, good. The resultant force. And the resultant force becomes 0. Okay, good. So when terminal velocity achieved, A becomes 0, resultant force becomes 0. Why the terminal velocity achieved? Because air resistance is proportional to velocity. Air resistance is going to build up. Is it going to build up continuously? No. You're going to build up until the air resistance balance the weight. Once it balances the weight, acceleration becomes 0. After that, is it air resistance going to build up further? It won't build up further. The 10 Newton of air resistance, that's it, stops there. Because of what? Speed does not rise. Therefore, air resistance never rise. Okay, so now come back. How's the VT graph going to look like? It's going to achieve terminal velocity. So what happened? The straight line graph, assume this is the straight line graph. Okay. Okay. Let me write this. Straight line graph. The original straight line graph now tend to become what? Become curve down. Curve down, then achieve terminal velocity. You will achieve terminal velocity. This is your terminal velocity. V terminal. Okay. So it can be curve. It's curve down and achieve terminal velocity. Okay. This is how the VT graph looks like with air resistance. In exam, they will ask with air resistance, without air resistance. Without air resistance, VT graph is a straight line. With air resistance, the VT graph is going to be curved until achieve terminal velocity. Okay. Any questions? Okay. If you understand this, can you sketch for me how's the AT graph looks like? Is it going to be a AT? Is it going to be constant with 9.81? And terminal velocity achieved, A is what? And terminal velocity achieved, A is what? A
becomes 0.
So how's the AT graph looks like with air resistance? From
Curve
9.81,
down.
curve going down. Curve going down. We achieve 0. This with air resistance. Okay. So AT graph going to be curved down until it reach 0. It must reach 0. The moment where it reach 0 means the moment where the terminal velocity achieved last. If this is T1, okay, this is where the T1 happens. Okay. Okay. Okay, now, how's the ST graph going to look like? With air resistance. Without air resistance, make a curve. With air resistance.
Then a curve and then straight.
Very good, man. It's going to be curve. It's going to be curve. Then curve. Sorry, it's curve. Then straight. Towards the end, going to be straight line. So with this, it's going to be the T1. And very difficult for me to draw. It's going to be a curve, then straight towards straight. Okay. So the straight region tells is where the T1 happens. Okay. Any questions so far? Okay, so kind of messy. You have two sets of graphs. one with air resistance, one without air resistance. Read the question carefully. Don't straight assume no air resistance. You check the read question first. If got air resistance, you must use the second version. If no air resistance, use the first version. Okay? Let me test how well you adapt this by checking the question. We go back to the question. Okay. See the question already, yeah? Okay, this question. This is Juno 4. What's the answer? 1 minute for you. Everyone. Put your answer in the chat. Yeah. Okay. See how they put the wording, yeah? This one got air resistance or no air resistance?
Air resistance.
Appreciable.
Appreciable. That means they consider air resistance. They never neglected it. They said appreciable. That means there is an air resistance. So which graph? Good. Most of you D. So it should be D graph. Okay, it should be D graph. Okay. So D is the answer. The air acceleration will drop down to 0. There is a mistake here. It should reach 0. Okay. But I think out of this 4, the D is the best now. A definitely drops down. Okay. Give me the reason why acceleration is drop down. Because net force is reducing. Why net force reducing? Because air resistance is building up. Why air resistance building up? Because air resistance is proportional to velocity. That's why it's building up. Okay, you have the reason. So A must drop with air resistance. If they say air resistance neglected, this question, air resistance neglected, which one is going to be the answer?
A.
So good. So A is the answer. A is the answer without air resistance. With air resistance, D will be the answer. Okay, good. Okay, go down. We go more questions. Give a try for the graph. Okay. Yeah, this one. Yeah, this is November 2, question 10. Okay, read first. Hope all of you can give me the correct answer, majority. 1 minute for you. Read the question. Give me the answer. Read first. I scroll down. Yeah, scroll down. Which graph shows the variations of time t with the speed of the same ball falling in air at the same place on Earth? Or the above one without air resistance. The VT above is without air resistance. With air resistance, they're asking which graph. So all of you put down your answer. And when air resistance start to act, the V going to start to slows down. Okay, smaller. Okay, let me check.
Okay.
A B A D D. Majority go A and B. Or D, 3 of you. Okay, majority is went for A. Okay. Okay, is it A? A tells what? There is a certain point, the velocity with air resistance, without air resistance, it's the same. D tells what? The velocity is start to become smaller than the without air is without what do you call without D. Yes, good. The answer should be D. Okay, cannot be A. Why cannot be A? Because air resistance never. Okay, yeah, the air resistance never happen at the air resistance won't be when the air resistance start at the beginning. Okay, class. So please take down the diagram. Okay. So A cannot be the answer. D should be the answer, because air resistance already start to act at the beginning itself. So the velocity will slow down from the beginning itself. B never happened. B is against nature. Why? You see here, without air resistance, this is the velocity. The dotted line is the velocity reached. Let's say 1 second later, it's supposed to get 9.81 meter per second. But with the air resistance, you see the velocity going to be higher. How it can go higher? It can't go higher. It can't go higher. You have to be always lower than the dotted line. So D is the answer. C never happened. B also never happened. The question is answer is either A or D, but of course A, the velocity won't be exactly same at the beginning. It start to deviate from the beginning itself because air resistance start to act. Acceleration already slows down. Therefore, the velocity won't be as same as the without air resistance. So D is the best answer. Okay. Any questions here? Anyone? Okay, so those who got B and C cannot be the answer. A, okay, but beginning itself, the velocity will change. Okay, number 6, 202. What's your answer? One minute for you. Okay, so what's the answer? It's a ST graph. Oh, sorry, is it ST graph? Oh, which is the correct description of the graph? This is the graph of falling body. They never, you have to check whether got air resistance or don't have air resistance. It's curving down. So let's see who give the answer. All of you giving answer of C, D, 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 A. So majority go for D. Yeah, majority looks like going for D. Oh, B, C, D, B, 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 D, B, D. Oh, it's also a spectrum of answer. Okay. So A also many. Why is distance and air resistance negligible? Why is distance with air resistance is negligible? How the graph looks like for the first one? Sorry. Okay, first one, the distance versus time. Air resistance is negligible. Air resistance negligible is as T graph. How's the graph should look like? It should go like this, right? Okay, it should go like this, right? So A cannot be the answer. For the case of A, this is how the ST graph should look like. And air resistance negligible. How the B graph should look like? Anyone? B graph also they say air resistance is non-negligible. How's the graph going to look like? It's going to be curved, but towards the end going to be a straight line. It's going to be a straight line. So B also not the answer. B also not the answer. How the C graph looks like? Speed with air is negligible. Speed. Anyone? Speed with air is negligible. How the graph looks like? Going to be a straight line.
A straight line.
Yes. D is a terminal velocity, so it's going to be D. Yes. B versus D with air is. So answer is D. D is the answer. Okay, those who get D is good. The other graph should be like this. So for 6, answer should be D. Speed air resistance is not negligible. Speed with air resistance should look like this. Okay, and the other two ST graph, curve towards the end straight line happens with air resistance. So those who get A, B, C, please check back. The answer should be D. Okay. So any questions so far today's lesson? So today's lesson is still about graph, but free form. Okay. So you have two versions you have to remember: with air resistance, without air resistance. Okay. With air resistance, you should be able to explain why the air resistance causes what do you call? So this is the description here. You have the description here in the notes. Oh, sorry, where is it? This is the description here in the notes explaining. Okay, sorry. This is the description in the notes explaining why what the air resistance effect. You read here, you can understand. So in practice, the air resistance is taken into consideration. The velocity of the falling object will not increase time indefinitely. Air resistance opposing motion tend to increase. So this is the keyword: increase approximately with square of the speed, or you say speed. This is 1 mark. Okay, air resistance proportional to speed, 1 mark. And initial acceleration of g attributed to the g. As the velocity increases, the air resistance become more significant. This causes the effective downward acceleration to become progressively smaller. This 1 mark, progressively smaller, 2 mark. The velocity of falling object will increase decreasing rate, or this will increase at decreasing rate, the velocity. So finally achieve terminal velocity. It is the 3 marks you have to remember. Very common, they'll ask in exam, explain. Okay. So air resistance proportional to velocity. Therefore, acceleration decreases. Velocity will increase in a decreasing rate. That's a very beautiful wording. The velocity will increase in a decreasing rate until terminal velocity is achieved. Okay, 3 marks. When terminal velocity achieved, two quantity becomes 0. What is that? What is that? Acceleration becomes 0. Net force becomes 0. Okay. Okay, good. This is today's lesson. Any questions before we stop? Okay. So class. So tomorrow, what we're going to do is, you can check the notes. Tomorrow we're going to do the SUET, the 4 kinematic formulas. These 4 kinematic formulas. Okay. Then we discuss question about that. Okay. So be prepared for this 4. Okay. So if you don't have questions, we can stop here. Any questions?
No.
No questions. Okay. So see you tomorrow. We continue with the SUEL tomorrow. Okay. Thank you.